Yesterday we discussed about group by key, reduce by key, aggregate by key, and even we discussed the differences between uh, all these. So I hope that you were okay, right? Means you understood that. The main thing is not how you are getting the output, but how internally this is working and which one can be optimized in which other scenario. So why I focused on that? Because most of the time we get a question, okay, what is group by key and what is aggregate by key, reduce by key, what is the differences between that? So if you are clear, you can explain that nicely. Otherwise, maybe if you are stuck, then it is something that you do not have proper understanding and all. So these are the small things. Along with the exercise, you can have a look for a single line. Okay, what is this and how this is working? If similar output means yesterday we see that group by key, sorry, this reduce by key and aggregate by key output was same, but internally it is behaving differently. Then that things we can have a look. Okay. Then finally, I will go through this group by the next one. So let me uncomment this. So this co-group is something we use for RDD. Okay, let me quickly open the Word document. Yesterday I created this white transformation. So in this white transformation, this is the data I did for group by key, reduce by key, and whichever not supported, I have simply mentioned that aggregate by key is especially for RDD transformation in PySpark and can't be directly used with DataFrames. However, we can do that by additionally working with group by key, then having some aggregate functions on top of that. Like here I have done in the above one. Here you can see where it is, yeah, group by and then some aggregate function and then you can do. So means that's the alternative. Directly you can't. Direct option is not available. This is dedicated for RDD only, either group by key, reduce by key, or aggregate by key. Then join and so join. You have to take care of that and then join with. Okay, do you see co-group? This is co-group. So I have mentioned in this document in this exercise until join with operation. So for this co-group, what this is for already groups, customers and transactions. This is the data above. I have created customers and transaction data. If you look at here, this is the transaction detail. This is the customer detail. By customer ID and product produce a tuple of list. And for data frame, not directly applicable to the data frame. So here I have mentioned co-group in operation is it is typically for RDD where the database where it groups the data based on the key and performs a join like operations on the values from two RDDs. Where data frame and if you want to work with the data frame, then this kind of operations is not directly available. So the thing is how many transformations we have either with an arrow and white. Some we can work with both using some of the transformation and few are dedicated for RDD and few are dedicated for the data frame. So if you want to get the similar kind of output, do the similar activity, then we have to go with alternatives and not the direct one. So here for this co-group, how this works, let's say we are having two data frames. So we are having one RDD employee and one RDD department head, where this is let me copy this at the same place. This is the employee RDD and this is department RDD, department head. So for that, if we wanted to group that by the department, then using this lambda function, we can go with index. Indexing we see yesterday, right? How you can have 0, 1, 2, 3, 4 accordingly for each of the column means the data sequence, and then you can call that to collect how you want to collect the value. This is map values. So this is going to collect the values for the values as a list. Let me run this. And I have not commented the above one, so this will be taking lots of time. I need to remove all the things. So, okay, first let me go through the output. So if you see co-group.dd, this doesn't look so good. What it has that, okay, co-group.dd, this one. This is for the sales. What is the name? Means employee and department head. For marketing, there is nothing. Need to check why. And engineering and HR, all are having some data. For marketing. Okay, marketing was not available in the department here. That's why this was blank. So output is like this. Okay, so this is simply grouping the data from both of the RDD based upon the key. This is the sales, this is marketing, this is engineering, and this is HR department wise. And what we had given in the logic here. Okay, there was nothing. Only join this, co-group this, and this was with the 0 and 1. Okay, fine. Let me uncomment all these things. This is taking lots of time. So this segregate by key we already done yesterday. Order by also we did. Sort by as well. Join I will not. Did we check out the join yesterday? Yes.
No, join, no, I didn't, sir.
No, right? Let me do this quickly before moving to next. I believe that you people are good with join.
Yes.
Yeah. So you can completely simulate that with Spark as well. If we keep all the things, what happens? This take lots of time for processing because this is going to process each and everything, right?
Right.
And this is already salary. Then this is for the join. Okay, this one we see yesterday for join, where we had changed the key and value with first name and last name, and based upon the ID we had joined here, right? This was kind of inner join. So based upon key, I can say ID. Then prefer sort and merge join. This is a kind of configuration setup. Anyways, I have collected most of the configuration setup, not all. And then I will be sharing that. Means we will discuss on that how this can help you for the optimization and other things as well. Just give me 1 minute. Okay. Then we have left outer join. So for left outer join, what it does, this left outer join transform performs a left outer join, ensuring all keys from left already appears in the result, even there is no matching key. So just like your SQL, if we are trying to join all the data will be populated from the left side table, left side data frame or RDD. And when if there is no matching from the right, then that will also be there with the null. What it means from the right side, whatever not matching, that will be coming as null, but it will be pulling all the data from the left side. Let me uncomment this. We will take all the joins all together to just for the better understanding. So this is left outer join where employee this is on the RDD, not the data frame, and we can apply the same with some syntax change. Uh, the RDD also and data frame also. So this is one of the employee RDD, and we are doing left outer join, and this is the RDD department head. What is RDD department head? Just look at this. RDD department head. This is a RDD and not any column name. So we are joining the RDD to RDD. Then this is the output of that, and similarly for right outer. So for right outer, here this is going to pull all the data from the right, and whatever is matching from the left, that will be pulled out, means based upon the matching. If nothing is matching, then if something is not matching, then that is going to populate as null. And then this is again, this is same, only this syntax is different if you compare the same left outer and right outer join. So in SQL we do right left outer, right outer, keyword is different, right? Here keyword is different, that is in camel case, but concept is same. Similarly for full outer join, we will be doing this with data frame as well. So for full outer RDD, again, only if you see only keyword is change. This is one of the RDD and this is second RDD, and you want to do the full outer. So this is going to pull the data from across the RDDs, from both the RDDs. So let's run this. Just give me a minute, okay? Okay, so let's see the output now. If you check here, go group RDD, I think nothing is printed. We can, okay, this is the joined RDD. This was for, let me copy this full outer, and we will go to notepad, or let me take here itself. This will be more visible. Here down to RDD, full outer join. Okay, this is for the data frame operations. Full outer, this one. Okay, so if we see here for the joined RDD, this is only for the matching because marketing is not in the department one. So marketing is not appearing here, only from this. Okay, this in this department only these are there, and in employee one, marketing is also there. So we had did the join, and then this join marketing is not available because this was not in the data in that one. And then left outer join. So from the left side, sales, and then marketing, and then engineering, and then HR, all are there. Coming to right, in right one, this is this and this, because in right we had only three, and in full outer we have sales also, marketing also, engineering also, and HR also. We will be doing the same operations over the data frame. Then we will be getting the output similar like you get in SQL side in the tabular format. Okay, because here you are not getting in the same way. This is just collecting the data as a list, and not this is not giving in the tabular format with row column where you can get for the matching the data, not matching then null. You are not getting like that. So we will be when we are performing the same with data frame, then you will be seeing the differences. But here you can see one thing. You see here full outer join, this keyword, right outer join, left outer join. So this keyword is a bit change, means for some of the operations, if you are doing something, maybe you can get the same. But here for the join, this will be bit different syntax wise for the RDD, and means between the RDD and between the data frame. As if I show you here, uh, here I have did something right outer join. You can see how right outer. So syntax wise, it will be different between RDD and the data frame. Now I will remove all the things from here. Whatever we do not need, instead of data, we need only data RDD salary. Then I will remove this thing also, and let me keep the data, or I guess this data is also not required. So I will be
Now, instead of deleting,
hmm,
could you copy this data into document and then share?
okay,
It
you
will
need
help out
this.
while exercise. Yeah.
Okay,
And we stuck somewhere, then it will be used for as a reference.
I will arrange and I will share. No, now this is taking lots of time, no? That's why. Where it is. Oh, group. Oh, group. We have did till this one. Now this is cleaned. Now we have sample data. Doing the data sampling, we have already seen this in another as well, right? But anyway, let me do this. This is employee data. This is the data frame. And again, here I am creating department data. And then, okay, I have not taken that data sampling. Okay, no, this is sample data only. Sample data for this is not any transformation. Okay. Then we have next join operations. So here I am going to do the performing the same joins with the data frame and not with the RDD like how we did in the previous example. So here if you see this will be like your SQL one inner join. So for inner join here this is the change you have to perform. You in that you have seen left outer join, right outer join, full outer join. That was the keyword. Here you have join and in the bracket you have to give department df means the data frame you want to join. So simply you can say df joined df equal to joined df equal to df1 dot join df2 like that. Okay, so this is simple because you are not giving any condition, any statement, anything. But here you are saying dot join then which data frame. So this is same what we are what I gave you here for the reference. Then on we wanted to join based upon some column, right? So here if we see the department, what is this is the department column in the department data frame. And then how you want to join. So this is where you have to make the comment either you want to join inner or outer or left. So this is the keyword you have to take care. Okay, so eh, make sure that syntax you have practiced because this also you if someone is asking about joins if you are good to explain sometimes they may ask if you can write a syntax. So the main thing is they want to know either you are hands-on or not because let's say if you are doing this kind of thing then that is okay but this is very simple, right? And if you are doing like this if you are doing like this then they may understand okay you have to read and you have the knowledge. So you can keep in mind that you are giving join dot join then data frame name then how the column name and then the type of join inner join outer join full outer whatever you want to left right and all. Before you join this so here is the data sample data was same. This which two belongs to engineering, two belongs to HR, and again one belongs to engineering. That means from engineering there are three people, and in department engineering, HR, and sales. So let's run this. What is the error? Name DF is not defined. Okay, so if you see, this is the inner join DF. In inner join DF, we have engineering three times, HR two times, and this is the department head. So we are getting department head data from the another data frame. Here we have department head, right? This is the department head output. So from this department head for each one, for engineering, he is the head. So he this data got populated here for HR and for sales accordingly. Then we can go to next one, inner join. Let me.
Nana, can you scroll up to the first data frame
Yes,
and to see the data? Okay.
this is the data.
So here it is automatically putting the column at first position on which we are doing the join, right? Like
Mm.
we are joining on department base, so department is the first column, and then it accordingly it arrange the other column.
So here department is the third column, right?
Yeah, in the output I'm talking about. We are
What
joining
happened
based
about?
upon the department, right? So department is coming at first.
Okay, okay. This has taken as first one, and you are saying that this should be employee ID name, salary department head. Then yeah, right. So this is taking randomly. You have to rearrange the column name if you want. Like we have select statement in SQL, right? Then here also you can do the same. Select the column name in sequence, employee ID name, salary. Then in same sequence output will be there. Otherwise, sometimes it can be picked by means it can be random picked by Spark. because we are not defining that what is the syntax, but this is taking that. Okay. What is the roles and responsibility in the race in your job? Just I'm asking because you are very means deeply you catch up all these things, small things.
Basically, I'm on ETL, so I'm handling multiple applications at standalone.
Okay, because means these are the very small things, and um, very rarely people will be catching up. They will be thinking, okay, this is the output I got, but you are getting the thing which we will be getting in the last when we are thinking, okay, and now I am going to save the output, then I will be validating the data. Okay, if my data is good and if this is in proper sequence or not. If not, then I am going to correct. But at the very first sight, we are going to catch up. That's really very good. We should be like that. Everyone should be like that. So what this is going to do, this will be avoiding the rework because at the same time we can do the correctness. If we want to have a sequence, then we can rearrange the column name at the same time. Okay, now let's see the right outer. So for the for the left outer, for left outer, what we did, we have two things here. You can see we have left outer and we have left. So left outer join between employee df output will be almost same. There is no difference. Okay, only that this is the keyword change. Both are supporting. Means if you are using any out of, then that is okay.
Here, DF is same in both the
Ah,
units.
correct. DF is same. There is no difference between the data. Now here, if we see the left outer join, then again, this is for the engineering 1, 2, 3, 4, 5. Then salary, Mohit safety. It is same. And left outer join means what? Cells is not in this picture, right? If we could have enable left also, let me do that. I have commented that. Let me run one more time. If you see, this is left outer. So this for this one we have engineering and HR. I think that it's same, right?
Yes.
Only row is here and there, but it is same. So this is inner join and this is left. Okay, that is okay only. Then inner join means matching one, right? This is left and this was the left data, but left we have cells also, right? Okay, let me check for the right one. Then let's see this because I need to check it. This is for right outer. Now, if we see for right outer, cells is null because it is not in the another data frame, the department one. And here Raunak Verma. But this is for right. And then we have full outer join in a similar way, where this is going to pull all the data from both, regardless of matching, non-matching. Then this is full outer join. Anyways, our data, our output is almost same for the previous one, right? Because we have a small data sets and either we are doing right outer or full outer out data in the output is same, only sequence is different. Okay. So like this, just like your table, like in table also you get this null, right? Whatever is not matching, you will be getting means not matching means either not matching or you do not have the data for that. Then we get null and whatever is matching, then that is fine. So like that, this is going to work here in a data frame also. Then we have subtract. Subtract we had seen in narrow transformation also, I believe so. So subtract removes the element of one RDD from another RDD. This doesn't take means that this mostly prefer the first RDD, and this operation requires shuffling as it involves comparing the elements of both the RDDs, because this needs to check either that data is existing or not. If not, means if existing or not existing, accordingly this has to take the decision for the data subtraction. So here you have RDD1 where you have engineering and you have 1000 HR and sales. In RDD2, you have only engineering and you have HR, but you do not have sales. Again, for HR, your value is changed. Now you can see subtracted RDD, RDD1 dot subtract RDD2. Then either this is carrying for key only or this is carrying regardless of values as well, that we can check. So if you see here, this is not checking for the value. This is taking for the key only, right? So randomly whatever is picked, that is okay. This is taking sales and HR, sorry, sales and HR, and another one was filtered out because this is not available. Sales and okay, no. Engineering it was same and HR it has differential. Let me do this for more clarity. Then output is sales
Because the
only.
value was different now
Yeah,
on
let me copy
yeah,
this. Yes,
800 and 850.
correct,
So
correct. So here in this case, output is this one, when this value is same. So this is saying that okay, cells is that it means that cells is not existing. So whatever is matching, that is okay. Which is not matching, this is pulling out that. When we set this one 850 means with this value it's same. Then this is trying to match key and value both. So in that case, cells and then this one.
it will give the values from the left side, right? Whatever
Yes,
not matching, it will provide.
correct. So this is comparing with this one and whatever is not matching then from the RDD1, this is pulling out all the data. Okay, this is the data which is not matching from the another one. So this is working in that way. And data is getting collected as the list. Fine. And then we have sample by key. Sample. So for sample RDD, here I have taken some theory that samples RDD from a key value pair RDD and keys, allowing you to specify the sampling rate for each of the key. So sample key this is already based on the keys, and here in this example, engineering has a 50% chance and HR has a 100% chance because we are giving here a 0.5 and 1.0. 1.0 means 100% and 0.5 means 50%. How much we are doing the sampling. So with fraction you can give the key, and for each of the key you can give a percent, and according to percent you are going to get the data. What is the data? Here engineering having two and HR is also having two records. So if we are saying 100%, that means we should get all the output from the HR. If you are saying 50% from engineering, then most probably we should be getting half of the data. Right? And if we are doing sample data, then HR should be 100%. So 1 and 2. Both the records are in the output. For engineering, only one record is in output because we are saying engineering, and here 0.5% only. So like that, we can do the sampling with the percent. Here with replacement true and false, yesterday we seen, right? What is that? What is for day before yesterday for the true and false? In one, that is going to make sure that this is not getting the duplicate data. It means an uniqueness maintenance. If you are having false and if you are having true, then this will not be maintaining the uniqueness. Same element can get repeated. So here if you see for sample RDD, this is HR 100%. Sample RDD. Okay, what about engineering? This is not printed. Sometimes it took output as randomly. So this is saying HR, it is giving data for both, but it is not giving anything for engineering. It should have given. When I ran this previously, this was giving this output. So let me do this also 1.0 just for testing. 1.0. One point zero. Now both are 100. So we are getting 100%. Engineering also both the records and HR also both the records. But why this is not working with 50%? Anyways, I can't give any other percent because I have two records only. 0.5. Okay, this time this has taken. Sometimes it does something else. Because of only it is picking the randomly data. That's why there is no such logic behind this. So with 0.5, this is taking this 50%. And if we are giving 100%, then that means for based upon the key, whatever sampling we are looking for, if we want that, okay, for this kind of data, I want this percent sample, and for this kind of key I want this much, so we can arrange that. And then let me, and not uncomment, let me delete it. Anyways, I will revert all the deletion and I will share this notepad itself. Then combine by key. So for this combine by key, we have okay. So here we have a RDD with HR and engineering. Combining by key. So create combiner, and then this is going to take, and the next step merge value and then merge combiners, means internally how this we are defining here, okay, to work with it. And then finally getting the output. So combine by key uses custom functions, okay, and create a tuples with initial value and do the count. Then merge value for each key and adding the salaries and counting the occurrence. I have just explained this. And then merge the result of two partitions here with the last step. We are doing the merge combiner. If you do this, then we are finally good to check the output. And now let's see this. If you check the output for the engineering, what this is doing, this is doing the sum and occurrence 2 3 whatever. So we have two occurrence for each one, right? We are getting 2. Let's assume that I am making 3. I will be doing one more occurrence for HR. Let's make it 900. And then we can see here 3 occurrence is 3. So based upon that, it is taking the, this is the key, and inside this one the value, what is the total sum, and then what is the occurrence for that. So now we are with the pivot. So
We work on ID only, right?
sorry,
Combine by key.
right. So there are some limitations, and whenever so first of all, whenever you have the keyword key, that means you are going to work with key value pair RDD, and yeah, this is for RDD only. Then we have pivot. We for the pivot you have, if you have worked with Excel, have you worked with sometime pivot in Excel?
Yes.
Have you created pivot?
Yes.
Okay, then that's a good. So we can, this concept is coming up. Means initially we had Windows, and with Windows we were doing with Excel and all. Then we have SQL, in SQL also you can create the pivot table in DataFrame in Spark also. This is supporting very well with the pivot, which we use for restructuring the data by using the unique values from a column and create a new column. So here I have a sample data. So this is the sample data where we have this is the quarter wise, and this is the sales. This is assume that this is sales data, then you can just assume the revenue or some amount for this quarter. Okay, for this quarter, this for this person, this was the total sales. For again for quarter 2, this person did sales for this much, and this girl did for this much. So accordingly, then this is the column name for this data. And this is the data frame name. We are creating the data frame with sales data and sales column. Then trying for the pivot. Pivoting the data frame on quarter and summing the cells. What we are doing? Group by name. This is the name column, right? This is the name. And then you are trying to do the pivot based upon the quarter. This is Q1, Q2, Q3, Q4. And then you are doing the sum for the cells based upon the name, group that. Then check how is the output here. Anyways, I have printed output also. Okay, so if you look here at the output, just it seems I have did multiple times comment. So if we run it, then what this is doing? This is doing group by. If you see this group by, in RDD we had group by key, right? So group by key is specifically designed for RDD, and this group by is for data frame, and some operations which is not getting directly support in the data frame, whatever we're looking for, let's say group by key. Directly this is not supporting in the data frame. Then you can do the same operations using group by and with some aggregate functions like some aid, whatever you want to do. Let's not talk about pivot. If we are comparing with group by key, pivot is something different. So here, if we see the output is this. So for Priya, Q1 300, 600, null, John 600, Amit this much, and Priyanka this much. What wrong happened here? Because I am expecting like this. Q1, Q2, some cells. Q1, Q2.
After the data frame, I think output
Sorry,
is coming as per the expected.
this
Maybe
one.
the earlier output was due to different data frame, and later on you modified the data frame.
It can be. Sometimes I do that.
Because there are four names, and
Yeah,
we
right.
have
Right.
four quarters as well.
Right. Here I have Q3, Q4 also, but in output this is not. So this is the data for Amit, and so this is doing the rearrange. Rearrange in the sense this is Q1, Q2, Q3, Q4. This was the column name, and here, sorry, this is the row value, and this quarter row value is getting restructured as the column name, right? So for column name Q1, we are getting 300 for, so this is expected only. What is happening? We are using pivot. Pivot means we are trying to restructure the data. While restructuring, this is getting this row value is getting converted to column name. That's okay. Q1, Q2, Q3, and Q4 with uniqueness. Now for Priya, Q1 is having the value. Q2 is also having the value. Q3 and Q4 there is no value. For John, John is having output only in Q4, and Amit is present in Q1 and Q2, and Priyanka is only in Q3. That is fine. Okay, that is okay because this is quarter. Then let me uncomment this and I will run it. This is wrong. This is not supporting. Object has no attributes, so okay. I was expecting here for some value, but what is wrong here in this transformation?
For some, I think there is no values for the same quarter. Now it will sum up based upon the quarter wise. But we have one value for each quarter for a particular name.
Oh,
Why
is it
yeah,
Q1,
see,
Q2? Okay, let me do this. Oh, but we want to do group based upon the name, right? Okay, you are saying that we have given quarter. So based upon the quarter, this is doing. Okay, let me just keep one data. And Q1, let's 400. Let's run this. For Amit, 900. Yeah, this is doing. You are correct. So as value is single one only. This is not getting applied because this is doing grouping by quarter, and for each of the quarter there is single value. So how it will be taking up? Okay. So here main thing for the pivot is not the doing sum and all. Main thing is this one. How you are restructuring the data. Your data was whatever data we are getting in the row, we are converting to column. So sometimes what happens, let's say you are getting a input JSON, and in that input JSON you have uh, okay, let's assume that we have this laptop as a device, and you are getting device data. In that device data you will be having JSON nodes, let's say hardware, software, drive, then it's a processor, and then motherboard and all. Multiple details you will be getting. That will be coming up as a row value, right? Let's assume that some other analytics team is there. Someone wanted to have some dashboard for the disk only, for the motherboard only, for the hardware only, for the software only, something. Or let's say someone is looking for hardware only, someone is looking for software only. In that case, whenever you have two records here, hardware and software, you can convert that as a column name, and then for each of the column name you can have your aggregation. So in the JSON and XML we get this kind of scenario more, where we have some data. That data we are expecting to be in column names, and then for that we are getting some other manipulated or related value as its record, as its raw data. In that case we can do the data restructuring using pivot, uh, and this will be helpful. So this is mostly helpful in most of the use cases I have seen for restructuring the data, because most of the time you are working with that. Let's say you are working with some heartbeat data, click stream data, or maybe some other customer data. In that let's say you are having a customer, and customer is working, same customer is working for multiple departments, or you are having the departments, and for each of the department there are the employees. That department is coming as the raw value. But if you want to do the analysis not based upon the employees or ID, you want to do based upon the department only, then simply you can convert your department, all the department, into the number of columns, and then you can go ahead. So these kind of requirements are, I will not say 100% frequently, but frequency can be 50-50. Means in most of the requirement you can have this kind of things where you need to restructure the data. So here this pivot transform the quarter columns into the new columns, quarter value, columns value. Columns, row value, row value into new columns, and compute the sum of cells for each name across the quarters. Okay, then let me uncomment this. What is this? So if you see here, this is Spark SQL. Anyways, we have not discussed yet about Spark SQL, so I will not go in very deep. Just as a high level, whenever you have a data frame and you want to do something directly with data frame API, then you can do. But if you want to run it as a SQL query, in that case directly you can't run from the data frame. Then you have to register it, create or replace temp view. We have temp view, we have a global view, and all. Both all are having some little bit differences internally. We will discuss that in detail when we are coming to Spark SQL part. But here I am just creating a temporary view where this will be capturing the data, this cells data as a copy. Okay, this will be holding a copy of data, and I am giving this name, any name you can say. This is, you can say, temporary table. You can consider this. Now, whenever I want to query the data from this data frame, then I am unable to query directly from this data frame, because this is data frame and this is Spark SQL is different. This is not direct data frame API. So that's why when we are doing create or replace temp view, this is going to create a copy of the data, and then we are giving this reference name. This is done. Now with this name we can query just like SQL. If you are good with SQL and you are not looking for any RDD or data frame API, don't worry. You can do each and everything just like your SQL queries. So here Spark SQL, select name, max. You can see this is exact same syntax, right? So select name, then max, then case statement. Case when you can say, let's say if I am doing this, then we do like this, right? Case when quarter equal to this, then this one, else this is null, then end, edge, from, then group by, then this is your complete query, then you are doing dot so like that you can simply run like your SQL query, and this will be working completely fine. Let me show this. So here if you see group by name, select from cells data. You see this was the temporary name, a reference name I gave, and here I am calling from the same. If I take this one, because this is my data frame name, then let me run this cells df. This is going to fail. Why? Because this is not having, so this is not simply supporting. Okay. And if I, it is saying some indent issue. So let me first remove that indent one. And now I will change this as cells df. Cells df, then run this. Okay. Now you see what is the error. Analysis exception, table or view not found, because this is looking for table and that is data frame, and we are running a select star from just like SQL query, and SQL query can't be directly perform over the data frames. Okay, so this is saying table or view cells df cannot be found, and verifying the, it is suggesting verify the spelling or correctness of the schema and catalog. If you have something wrong, if you did something wrong, if you did not qualify the name with a schema, verify the current schema. So this is just suggesting to do the verification. So let's keep this name. We gave for a temporary one, table view. So this is just like a view, temporary. Temporarily it has copied the data, and from there we are going to copy, query that. Now this is success. And if you see, now this is coming, okay, name, then max. We are taking a Q1, right? Then Amit, then John, then Priya and Priyanka. So based upon the query, you can change the logic, whatever you want, how you want, and accordingly, this will be giving you the output. So this is for, here we had a case statement where quarter equal to Q1. Then, so this logic itself is for Q1 only. That's why the output was like that. But anyway, this is complete SQL. So you you try with the varieties of code, logics and all. Then let me comment out. Okay, now group by. So group by key was there, which was for RDD only. And if that is, if you want to do the similar kind of operation with data frame, then group by is the option which you can apply. Now let's take this. So group by groups rows based upon the specified columns, and this is similar to group by key in RDD. Here we are taking in a Spark we have functions, and inside that you have lots of things to import. Whenever you will be checking, you can get that. Here I am taking functions as f, and then grouping the data. So employee TF group by department and then doing the aggregation. Here f is just coming from here functions as f, then average, getting the average salary, and this is the alias. Alias means salary you wanted to print as average salary, like we see in SQL also, right? Like select a salary as employee salary, in department as employee department, like that. Here we are giving the alias, and then our column salary column name will be displayed with this average salary. Let's print this. So this is average salary for each other department. For engineering, this is taking the average one, and for HR also this is taking the average one. So accordingly you can run with group group by. Again, this group by or group by key, this is a very costly operation because this works globally with the data, not with the local partitions, how we discussed yesterday for uh, reduce by key and all. Okay. But again, this is required. Whenever required, then we are going with it. Then let's move with next. Group by. Window function, you know, right? In SQL, you know, Naresh?
No, I didn't use.
Okay. You never use window functions. This is really very good thing in SQL, right? And in interview part also, if someone is interviewing for a Spark SQL or SQL, interview can't get completed without window functions.
Is it?
Okay, no issue. So we will be taking the next. Here with the join. So join is used, anyways, we already seen the join, right? Join is used to join two datasets and return a new dataset with the tuple containing both rows from the both of the data frames. So joining employee DF and department DF with join. Here, what we are doing simply as we had already seen, join, then another data frame name, then column name. Sorry, not column name. Here we are giving the equal to statement, which we say no, where a dot id equal to b dot id or employee dot id equal to department dot id. We do the comparison, right? While doing
Yeah.
the join. So similarly, we are doing this data frame dot department column equal to department data frame dot department column. So we can apply this kind of syntax whenever we are doing the join. If you do this join df and false, then you will be getting the output accordingly. So this is just a syntax for the syntax purpose I have mentioned here, that you can do like this as well.
Earlier we see the different syntax, right? Or data
The
frame
same
only.
same here also you can use. This is just a addition.
Okay. Different
Okay.
ways.
No, not different ways. Let's say you are doing left join or right join, but in that join, maybe you have a filter condition also. You can have, right?
Yeah,
Or you can't have.
yeah we can
Let me uncomment the another things because all the output has been printed and we are not able to get it. Now let me run this. Here, if you see, we have a department joined df. Again, we have to print somewhere. Okay, yeah. Here we are saying department equal to. So what you see here, the difference is joined df, you are joining employee df with the department df, and simply you are saying employee df dot department equal to employee df dot department, means both are matching. And here you are saying you are joining with department df, then on department column. This is the replacement for this one, right? And then you are saying how inner join. If you are not giving inner, means how, then automatically this will be taking the default join only. We have printed both the output. Now you can see here what is the output. What is the difference as you see? This is employee ID, name, forget the sequence, okay? And then and one thing you can see, whenever we are doing on column, then always this is coming as first, right? Based upon which column joining is happening with the second syntax. So employee ID, name, then department, then salary, then department. Okay, here department is here and here, okay, here it is 2 times. Here it is duplicated. And so we have to take care of that whenever you are doing it. But output wise, almost this is same. There is no difference, right? Everything is same instead of this column is getting duplicated. So that's it. But output wise, it is okay. So you can go with any, either you are going with this one or you are going with this one. Means you can apply a filter statement like this as well. Or simply you can define the column name. Now truncate. You know about truncate, what it is?
Yes.
What it is?
Okay, with delete the data from the table from the physical side as.
No, that truncate is different. When we see truncate table name, right?
Yes.
Then it will be dropping the data from that table. That is not the thing. This is for the output only. So truncate equal to true, truncate equal to false. Let's say you are having 10 columns and all the columns can't be fitable to your output, because temporarily we are printing the output, right? In that case, if you are doing false, then it will be printing the entire output in the entire string. If you are doing true, false, and if you are doing true, then it will be truncating the data. Let's make it true and run this. Anyways, we have very less data, so we may get, but I will change the data to get the things clearly. So we are getting the exact, no, there is no difference. Let me change the data somewhere. So we are saying truncate equal to true, and this is joining based upon the imply df. This is imply df, and here let me just take this name. Okay, just assume that this is very lengthy. Now print it. What do you see? Do you see the entire? No, right?
Yes.
This has truncated. We see we give truncate true. So if truncate true means this is not going to care about. This is just giving the output for the reference. Now if I make truncate false, but this is just the output display. This is not truncating the actual data like SQL it does. But you can apply truncate whenever we are applying SQL query, right? You see here above we have did. So in the same you can SQL like query you can run truncate table name. This will truncate the table because this is supporting SQL as well. But here it is not. Now I did truncate false. You see the truncate false what it has done. Now it is giving the entire, right?
Yes.
This is not truncating. So this is the difference between truncate, true and false. If you have a, let's say you are working dealing with the JSON and all, and that JSON is very lengthy. If you are simply doing so, then this is by default, this will be taking true and this is going to print half of the data, whatever is fitable into your console. But if you want to debug and all, and if you want the entire data, then you have to make that false because by default this is going to take true. We did not give anything. So you are giving here true and sorry, false. And again, you have one more parameter, let's say 2. Now let me run this. So now how that worked 2. 2 means we are giving the limit, right? Number of rows. How many rows you want to display. So here in so you can define number of records you want to display and true and false. Either you want to truncate the output or you want the exact string, whatever, either regardless of its length, you want the original one. Okay. Then this is something like that. Then we have entered into main data frame APIs and all. Now we have with column. With column, this is in the data frame that is for adding the column because you can have a data frame or a data that data is having, let's say, 4 column or 5 column, and you want to add some more column additional. Then you can use with column, and with column you can add a new column. Then with column is used to add or replace a column in the data frame. Adding a new column bonus here in this example to the employee data frame. We have already one employee data frame, right? Now we are going to add a bonus column, and here by adding a new column bonus, calculate as 10% of the salary. We have salary column also. So we will just assume that okay, based upon the salary, 10% of the salary we are going to get as bonus. What we are doing the syntax, employee TF in the you have to take the data frame where you wanted to add a new column. Then with column, then you are giving bonus column name, new column name, then data frame dot salary. This is your logic for this column. How you want to populate the data? If you want to populate the data, let's say you want some literal data. I will be doing it and I'm just going to delete this. Okay. And I'm saying simple. I'm not doing anything. Then employee with bonus. Let's show this. Hmm, what's wrong? Okay. Let I have to import.
To work with this column, you need to import some library.
Yes, yes.
Give it and
So here I have to give this lit is for in this is in SQL function only. So let me do here. PySpark from PySpark dot SQL dot functions import lit. This is for literal value. Import lit, and then we can run this. Let me run now. What do you see? We have added a bonus column, but bonus column is having some literal value. And anyways, we are not going to expect this. Okay. So let me correct it. Means we are going to put a logic. First of all, let me correct this data. Okay. And then we can calculate whatever you want to calculate. So previously, I will take the previous calculation only.
And some percent from salary.
Right. Let me reword it. This was the logic. Then I need to again reward this. This is looking bad in the output. You know, there are two kinds of developer in the industry. One developer who tried that, okay, I will be getting the output and my job is done. And another kind of developer is who will be getting the output, but he will keep the code clean. Have you seen this kind of developer? Both kind of developer?
Yes.
Someone's code will be just kind of rough. If you are trying to
Yeah.
understand, you have to give 2 hours extra. Maybe in that 2 hours also, you will not be able to understand. But that code is working fine. But they will
I
be having a
usually
lot.
with second type of the developer only.
Right. And yeah, and for enhancement, give the same code to the same developer. Then the same developer is going to take 2 days extra just to understand his own code. Because first time whatever he did, he will not think about removing unnecessary things and commenting unnecessary things, deleting and not which is not required, because that time we know very well what is required, what is not required when we are in the development phase. After 3 months, if you will ask me only whatever I did, why you did it, then maybe I forgot, I am not remembering. So at the same time we can have a complete cleanup and all, and we can make our code neat and clean, but some people doesn't follow that, and next time you hand over the same code, okay, you have to do this in enhancement, and the same member is going to take some 2 days extra just to understand their code. So we should not do that. Just I remember that by cleaning up this, Amit. Suppose if I do not clean the name, next time someone can think, okay, is this name is like that only, I am doing for testing, but maybe someone can understand in future. Maybe name is coming in the same format from the source, something like that. So we should follow all these things.
Yes,
Okay.
because same data frame we are using in multiple example.
Right, right.
Yeah.
No, I remember that because in my experience also I have seen multiple people who will be doing very good job, but they will not care about this small thing, and finally that is going to be a big issue, not at the same time in the enhancement time. And enhancement sometimes we get after a year, after 6 months, that is a big good gapping, right? And in that
Yes.
gapping, the original developer either that had left the company, that is one issue, or if that is already in the company, that person has forgot what he did, then that will
Yeah.
be an issue. So
Yes.
we should care about that. Okay, so now coming to this bonus, and whatever what is the logic? We are saying that okay, whatever salary is, take the 10%, 0.1. Now do this. Okay, then you see this was the salary out of 1,000, 10% 100, out of 1,200, 20% 120. So with column, we can add a new column, and then we can give the logic, because for this new column you need the data. If you want some literal data like I did with lit, right? So literal data means by default value. Default value, if you want to populate some in initial phase, sometimes what happens, you are getting the requirement that okay, we need the column, but we are not sure what kind of value we are going to populate. In that case, what you will be doing, you will be adding the column, but you can populate a default value. So later on, when you have to do that, you can take it as enhancement and you can apply the actual logic, whatever have to do. So the lit is for the default one, means whatever you want as just as a literal value, and otherwise you are going to provide a logic, and based upon that logic, your data will be populated. So you can manipulate the data and all. So let's say in the real time, the very common exercise is we get, let's say, I am getting one JSON. For JSON, I am having ID, I have name, I have city, I have department, I have, let's say, join some time, created time. This JSON was created with some time, right? Now, and this created time, what you are getting? You are getting in YYYY, MM, DD, and HH, MM, SS. Let's say, for example, I am getting test JSON and my file name is 2025, then 01, then sorry, today's date is 24, and then hour is 8:40, and let's say second is also something 12 dot JSON. You are getting a file format like this, and same file format you are getting into your inside column also. Let's say created time. Maybe this is just example you can take. Maybe you are getting in this format or file format. If timestamp is coming with the file name, then of course this will be in this format only. If you are getting the internal column, means inside any column, then maybe it can be something like this. Just I'm giving example. Then this and then this, something like that, right? We get like this, correct? Maybe with some time zone also, like plus 5:30 or
Yes.
something with time zones, and we can get. In that case, let's say you are getting the timestamp like this only, any of the format you are going to extract. Then created time you are getting in that in this way. Maybe you do not want this time zone, you wanted to convert into UTC, then you will be creating a column, right? Either you are going to manipulate the data here only, or maybe in the created date, created time, created date, not created time, created date. Your team is saying that okay, let's keep this one, and name take, okay, let's take any name, random name, then Bangalore, and then department, let's say IT, and then created date. For created date, your requirement is coming like okay, you have to take 2025, then 01, and then 24, but not the timestamp. Okay, then you are going to manipulate the data. You are going to truncate, means substring, right? And another requirement can be okay, you take the complete. So complete means I am taking 08, then 40, and then 12. So like that you can. Now I can have another, let's say file creation, file created date, file created date, and this is created date time. This is file created date time. So this is capturing the entire date. Now I am saying one more column. Let me copy this in another row. And then one load date. Two columns. In this column, I am expected that okay, this column is capturing the original, whatever we are getting from the source. But in this, I wanted to capture this one only. Then what I will do? will be doing? I will be adding one more column with file with column. Okay, and I will be doing the substring with substring. In substring, just I'm giving a reference. You can take any method how you want to do that. How you want to take only this one. You have multiple options to do that. Do. But substring is very common, right? When we are going to take that. Then this one and then load date.
I'll created date will be the original date and load date will be the date
Load
only.
date means, let's say you are processing every day thousand of files, lakhs of files. How we will be understanding that this is the file level date, right? Maybe this file level date can be 22 also. This is file created date, correct? And today is 24. In that case, when we process, this is a very common column name you will be getting in multiple variety of projects. Means I can say that I have worked with multiple projects, multiple companies, different client and customer, and I have seen naming convention can be different, but this is something we use for the reference. Like when we are processing, when you are
Yes.
get the file you get, that is different, but when you are processing, that is also one reference, right? Then we can say, okay, on this date we processed this much, and on this date we processed this much. So we can take current date.
Yeah, we are using MS identifier as a column name, and they have
Right. So this is
we are generating date and time.
Right. So this is very common column name you will be getting in the multiple projects entire the means in all the company I can see, because I have used this column a lot. Load date. Okay. And I always use in any of the data frame in any of the output file, because how I will be getting when I did this? I need a reference column. Then we can get if someone is asking me to get the states, so that okay, okay, in the last month you were dealing with the millions of files, then what is the states for the files, like yeah, in on which date, how, what was the count you got? So if I am getting the states, then Monday to Friday I will be having good count. Saturday, Sunday, it will be kind of nil or very less record, right? So we can have a state generation, or maybe someday I am getting 10 millions record, someday I am getting 100 record only, 200 record only. So we can get the clear picture what is happening. So current date. So in current date also, if you will be taking the current timestamp, then you will be getting everything. Year, month, date, then time second, then hour, minute, second, millisecond, time zones, and all. Again, you can select only this much, because we do not need the complete, right? This is fine. Why we are going to worry about timestamp and all? Because as soon as you take the timestamp, then that will become unique for every row, because this will be capturing millisecond differences. If you are enabling millisecond, then millisecond means for most, if maybe for not each row, because most of the rows are coming together from the PySpark that is getting work in distributed mode. So in the same millisecond, multiple files can get processed, but for many records, this will be kind of uniqueness. So if you want uniqueness for the date wise only, then take this one only. Don't enable hour, minute, seconds, and all. So in this kind of requirement, this with column is very much common. Okay. If you are not doing anything, then of course you are going to add one of the reference column. Okay. And then okay, you can have this in your exercise, how you are reading the column in the different styles with different purposes and all. Now we have count by key. So let me uncomment this, and then we'll take up this count by key. For count by key, I am taking count by key counts the number of occurrence for each key in key value RDD. So we have engineering. Okay, engineering are having two people. HR is also having two people. Count by key. Then count how many times each department appears in RDD. This is engineering 2 times, HR 2 times, just like your word count. Okay. Then you have cross join. Have you come across cross join anytime in the SQL? What it is and for what it works? What it does actually?
It's basically Cartesian product and it will multiply the output value between
Right.
both.
Correct, correct. So cross join performs a Cartesian product join between the two data frames or whatever we have, meaning all the combination. This will be trying to make combination with each one. Like this is engineering, this is the HR. Okay, so let's make a combination between HR and engineering. This is the different name, different department, different location. Whatever is in your input data, that is going to take care accordingly. Then cross join DF. Simply you are not doing anything, no logic and all. Simply you are applying the cross join. But this is really very costly operation. Why? Because you can understand this is
Yes.
going to compare with each one, right? And making a pair.
Yeah,
Then
each row.
if your data is sitting to 10, 20 nodes, then even if one column join you are doing, then that is okay. But this is going to do for each and every one separate. So that is very costly. So we should ignore whenever really until unless this is really not required, don't do this in the real time. But for POC, of course, we have to learn this. So this cross join returns a data frame with every possible combination of the rows from both the data frame, which can be computationally very expensive. This is very much expensive. If you have some GB of data and if you enable this, then you can see that only for this one transformation, this may take a one more 10 minutes, 20 minutes, 30 minutes like that based upon the data. Like that much difference as you can. Then cross join DF. Let me print the output. Okay, so see, this is the output. Name Amit. Then for the engineering department, this get matched with engineering also, HR also, sales also. Like this. So this was one occurrence only. But for all these three departments, this is going to have a combination. So that's why data got huge. Okay. And because all the data needs to communicate with each other, then only it can have the combination. This is a very costly operation. Computationally, this is going to take lots of time. So we should avoid it until unless this is really much required. Because see what happens in an interview also, you may get question. Okay, what kind of optimizations you have? Optimization means what? This is a simple operation. Whenever you are doing the development, that time only you have to think about that my processing should be faster. It should be running very smoothly, right? So you have to take care of each and everything, every step, whatever you are doing. Just take a look. Either this is good. This is going to take lots of time. This is going to do unnecessary shuffling. Can I have another alternate which can be more better than this? So you can care about all the things and that are going to have one of the optimization for an application. And if you are really caring for each of the corner cases, then trust me, your application will be always better than whoever is working in your team, your colleagues, maybe parallelly they are working on the same thing. Your application is always going to be the best one because you have care each and everything. You have think about, okay, what is this, why this is, and if something can be better, if this is taking lots of time, what else I can do. Let's say for this data only, for this output only, this is let's assume that you need cross join, you can't escape it. Okay, you are doing cross join, but your 1 GB data is now got converted to 3 GB data because three times replication, right, for each of the record. So just assume that your 1 GB data was originally, now you have 3 GB of the data. Now you need 3 GB space. What you can do? If you are going with the CSV, this is going to take 3 GB data. Can you go with Parquet? Then it can be some, it can reduce some amount because this is coming with Parquet. Again, snappy compression will be by default with Parquet. Or can you have another options also like ORC and all that can have much compression? So if yes, if that is in your option, it is available for you, that is working fine for your use case, then you can opt that. And in that case, you are going to apply one more level of optimization. And as your file size got reduced, your processing will be again faster. Because when this is trying to write 3 GB of file, let's assume that for 3 GB file, this is taking 3 minutes. If you are good to make the compression level, means because of the file format, or maybe you are applying some compression and you are good to convert this size to 1 GB again, then instead of 3 GB, again this is going to take 1 GB. Sorry, instead of taking 3 minutes for the 3 GB, again it will be taking 1 minute only for 1 GB, right? But data is the product of cross join only, means output is this one only, but you have managed it with the file formats, with the compressions, serialization, deserialization we have already discussed, right? Like that. So you have to think about how much you can and how much it can be more better, like that. Okay, so this is the thing. And next we have a window functions. I am not going to discuss about that because this is going to take time. Window function is really we need to discuss in detail. And this is a I can say you must have the knowledge. This is something. If you do
Yeah,
not
so
have, then you are going to get stuck. Okay, then we will be discussing about this in the next one. And I have shared the this one till what I have shared. I have shared with the join with. Okay, all the next I will be sharing. I will upload today. You have weekend, right? So just to go through that and try to complete. Okay, then
Anamika,
fine. Huh.
sometimes in the output side, we need to generate sequence number, right? The row number, you can say how many numbers are.
Correct, correct, correct.
So here, how can we do that? Like
That
in the
that is a part of window function. We have row
okay,
number. Okay, we are going to create all the thing. That's why I said no. This is going to take time. This see here
okay,
I have row number.
okay.
Okay, fine then. Let's meet in the next session. Have a good day. Have a good weekend. Bye.